data is everywhere. Every click, every purchase, every interaction generates data. This data is a goldmine of insights waiting to be unearthed. Data science is the key to unlocking this potential. Businesses use data science to understand their customers, optimize their operations, and gain a competitive edge. Data science is a rapidly evolving field. It encompasses a wide range of techniques and technologies. These help us extract knowledge and insights from data. From predicting customer behavior to developing new medical treatments, data science is transforming our world. Data scientists are in high demand. Companies across all industries are seeking individuals with data science skills. These skills allow businesses to make better decisions and drive innovation. This roadmap will guide you through the essential skills and knowledge needed to become a data scientist. We will cover everything from the basics of programming and statistics to advanced topics like machine learning and cloud computing. Every data scientist needs a solid foundation in programming, mathematics, and statistics. These are the building blocks for understanding and working with data. Python is the most popular programming language for data science. It is a versatile language with a rich ecosystem of libraries specifically designed for data analysis and machine learning. Some essential libraries include NumPy for numerical computing, Pandas for data manipulation, and Matplotlib for data visualization. Mathematics and statistics provide the theoretical underpinnings of data science. A strong understanding of linear algebra, calculus, probability, and statistics is crucial for developing and interpreting data science models. Don't be intimidated by the math. There are many resources available online and in libraries to help you brush up on these concepts. Start with the basics and gradually work your way up to more advanced topics. Once you have a handle on the basics, it's time to get your hands dirty with some real-world data. Data wrangling and exploration are essential steps in the data science process. Data wrangling involves cleaning, transforming, and preparing raw data for analysis. Real-world data is often messy and incomplete. You'll need to learn techniques for handling missing values, dealing with different data formats, and transforming data into a usable format. Exploratory data analysis, or EDA, is the process of summarizing and visualizing data to gain insights and understand its underlying structure. EDA techniques include calculating summary statistics, creating histograms and scatter plots, and identifying outliers. Data is often stored in databases. Understanding how to interact with databases is crucial for any data scientist. SQL, or Structured Query Language, is the standard language for communicating with relational databases. Learn how to write SQL queries to retrieve, filter, and aggregate data. Big data technologies have emerged to handle the massive data sets generated by modern businesses. These technologies include distributed file systems like Hadoop Distributed File System, NoSQL databases like MongoDB and Cassandra, and big data processing frameworks like Apache Spark. Familiarize yourself with these technologies and their use cases. Section 5. Machine Learning, Making Sense of Your Data. Machine learning is a core component of data science. It allows computers to learn from data without explicit programming. There are two main types of machine learning: supervised learning and unsupervised learning. Supervised learning involves training a model on labeled data to make predictions about unseen data. Common supervised learning algorithms include linear regression, logistic regression, decision trees, and support vector machines. Unsupervised learning aims to discover patterns and structures in unlabeled data. Clustering and dimensionality reduction are examples of unsupervised learning tasks. Model evaluation is a crucial step in the machine learning process. You need to assess how well your model generalizes to new data. Learn about different evaluation metrics like accuracy, precision, recall, and F1 score. Section 6. Advanced Topics, NLP, Reinforcement Learning, and more. Once you have a solid understanding of the fundamentals, you can delve into more advanced topics in data science. Natural language processing, or NLP, focuses on enabling computers to understand and process human language. NLP techniques are used in applications like sentiment analysis, machine translation, and chatbots. Reinforcement learning, or RL, is a type of machine learning where an agent learns to interact with an environment by taking actions and receiving rewards. RL is used in areas like robotics, game playing, and autonomous systems. Deep learning is a subfield of machine learning that uses artificial neural networks with multiple layers to learn complex patterns from data. Deep learning has achieved state-of-the-art results in areas like computer vision and natural language processing. Familiarize yourself with deep learning libraries like TensorFlow and PyTorch. These libraries provide the tools and frameworks for building and training deep learning models. Section 7. Visualizing your findings, from data to insights. Data visualization is an essential skill for any data scientist. It allows you to communicate your findings effectively to both technical and non-technical audiences. A well-designed visualization can reveal hidden patterns and insights that might not be apparent from raw data. Master data visualization tools like Tableau, Power BI, and Matplotlib. These tools provide a wide range of charts and graphs to represent your data in a clear and compelling way. Learn the principles of effective data visualization, such as choosing the right chart type, using color and labels effectively, and avoiding clutter. Section 8. The Cloud and Beyond. Deployment and Scalability. Cloud computing has revolutionized the way data science is done. Cloud platforms like Amazon Web Services, Google Cloud Platform, and Microsoft Azure provide on-demand access to computing resources, storage, and data science tools. Learn how to leverage cloud services for data storage, processing, and model deployment. Familiarize yourself with containerization technologies like Docker and deployment tools like Flask, which allow you to package and deploy your data science applications in a portable and scalable manner. Section 9. Your data science journey, continuous learning, and career growth. The field of data science is constantly evolving. New tools, techniques, and algorithms emerge regularly. To stay ahead of the curve, embrace continuous learning. Build a strong portfolio of data science projects. This will showcase your skills and experience to potential employers. Network with other data scientists. Attend industry events, join online communities, and participate in data science competitions. Remember that the journey to becoming a data scientist is an ongoing process. Embrace the challenges, never stop learning, and enjoy the ride.